Okay, students. So today we'll start the next topic, that is basically the density occupancy relationship. Before I go directly, what is density occupancy relationship? Let us know what are the basic relationship of flow density. Okay, already we know. What is the flow density relationship? Basically, simply what we know that flow is equal to speed into speed. Here speed I'm talking about space and speed. Okay, simply you can write spaceman speed into the, okay, in terms of symbolically I can write like it. Q is, the flow, and you can see the density is K, and average spaceman is S spaceman, and average. Okay, so from there we can derive the relationship, or we can find out the spaceman speed in other way. What I can write, that spaceman speed us is nothing but equal to, what you can write here from here, q into 1 upon k. I'm writing like that. Q is nothing but what, it is flow, and 1 upon density. What is 1 upon density? You know that what is density? Density is basically defined. Density is what? Density is the number of vehicles per unit length, right? So what is the 1 upon density or density inverse? Density inverse, or I can say 1 upon density, that is nothing but equal to unit length divided by number of vehicles. So length by number of vehicles is nothing but what? What is that? That is nothing but equal to, simply what we can say, space head we approximately displace, right? This total length, say this is the total length. This is the total length of the road, and say you have 5 vehicles. Say this is one vehicle, then say this is one vehicle, vehicle number one, and then this is vehicle number two, this is vehicle number three. Okay, so this is vehicle number four, and so this is vehicle number five. Once these 5 vehicles are standing on the road, and if you divide this total length by the number of vehicles, so it will give you the space. How many space? One, two, three, four, 5. Simple. What we can say that inverse of the number of inverse of density is nothing but length divided by number of vehicles, nothing but space. Okay, space area is sometimes denoted by, but I can say 1 upon k, nothing but like what I can write here, this equation of this bar s, what I can write, nothing but equal to q into 1 upon s. So as per this, what I can write, I can write what is the relation we got? We got the relation that spaceman speed, spaceman speed is equal to flow into, just remember this is another relationship. Okay, we need to know all this relationship, not only for finding out the relationship between the density of a, so this is the relationship that we got, the spaceman speed is equal to flow into space head. Okay, next, what is density? Initially we read what is here Q equal to K into US. What we have written. So what is K? K is equal to Q into 1 upon, okay, Q equal to K equal to Q into 1 upon. What is spaceman speed? Speed is nothing but equal to what? Distance traveled over time. Right? Now, if you take the inverse of this, take the inverse of here we have written one of inverse. Let us take the inverse. What is that inverse? Inverse is nothing but total time. What is this time? Time is nothing but is travel time. Right? Travel time over. What it is. So one of one is nothing but travel time over distance. That means for covering certain distance, you say the unit distance 1 meter or 1 kilometer cover. How much? What is the travel time? That is or inverse of the space means speed that we can find out. Okay. So simply we can say spaceless speed is nothing but is equal to travel time for unit. Some of the books mostly divided by maybe we can divide it by t. So simply what we can write 1/2 e power. Okay. So what is density? Density to flow into travel time per unit. Now let us see whether we can get it unit wise. What is density? Unit of the density is the density is nothing but a number of vehicles per unit, right? Number of vehicle per kilometer. What is the flow? Flow is the number of vehicle say per hour. What is travel time? Travel time is the what is T inverse? T inverse is the travel time say in terms of hour over unit distance. However, okay, so it's the by unit also. Next, we are interested to find out the average space headway. What is the relation between average space? Again, I will go from what I said. Q is equal to K into US bar. Okay, and then what we have written, we have read that earlier that US bar is equal to Q into T bar. Okay, if we just go back, let us give some equation number. Okay, so this is my first equation. Okay, equation number one Q into T bar. Then I have derived this US bar is equal to Q into T bar. Let us say this is equation number 2. Okay, then we have derived this. Let us say so what we know that spaceless speed is equal to flow into space area. The same thing I am writing here. This was equation number 1 and spaceless speed equal to flow into space headway. So what does it indicate? It indicates that space headway is equal to spaceman speed okay into 1 upon okay. So what is flow? Let us go there. Flow is equal to number of vehicles over time. So let us say time is the hour. Or even you can write out time. Hour means time. I am student of Q inverse. Q inverse or 1 upon it will be equal to total time or duration over number of. So if you know the total time spent by the vehicle and divide by the number of vehicles, what will you get? Average see in a particular road section I am telling in this equation I am collecting data for 1 hour and I have seen that by 1 hour n number of vehicle has crossed. So what will be the average what we can say time this time gap between two vehicles. and that will be nothing but equal to total time duration divided by number of vehicles, right? Total time is say whatever 1 hour, and total number of vehicles crossed that n. So what was the time gap between the vehicles? The time gap is what we call the time gap we call as the time headway. Now since we are taking all time together and all vehicle total time of the data collection time and divided by the total number of vehicles, so that will give you the average time. Okay. So this is nothing but average. Okay. So average time headway is unit, right? So you can write here. What we can write? V bar is so this is the relationship number. If you want to write it, what we have written here? We have written here is basically average. What was V bar? Average space headway is headway is equal to specimen speed. Specimen speed into average time headway. Remember, try to understand. Okay, so this is another. So I have given this relationship. Now I am interested to know what is average time. Okay, so I am writing again equation 4 here. What was equation 4? Equation 4, just say that B bar is equal to US into E. Okay, so equation 4 was basically average space headway is equal to specimen speed into average time headway. Now I am interested to know what is or how to find out the average time headway. Average time headway will be equal to what? US bar into 1 upon, right? So let us see how to find out. This is not correct one. I have wrongly written here. It should be reverse, no? This is what is that? It is H bar is equal to 1 upon US bar into right? Now see what is this? This is what? This average specimen speed. What is specimen speed? Specimen speed is nothing but what distance travel. Distance travel over if I write this bars. Bars of this is nothing but equal to total time or travel time. Travel time we can say over unit distance. You can convert it like travel time. Okay, so the travel time over unit distance is what? Just you go back. Somewhere we have written that travel time for unit distance is what? Nothing but equal to T bar. What is that T bar? T bar we have written earlier that travel time for unit travel time. So this US bar is nothing but equal to that is nothing but its travel time. Okay. So travel time over. So that will what we can write here be equal to T bar into let us say this equation number. What is equation number 5 here? I have written that average time headway is equal to average travel time for over unit distance, over unit distance multiplied by average. What is that? Space. Okay. So altogether we got five different relationships on the fundamental relationship of traffic flow. What was that fundamental relationship? That is nothing but equal to Q equal to K into and space means space. Okay. Now we will go for the actual relationship part we are talking about. That part is the density of the density. I think you know what are the definition of flow, speed, and density. At least, so if you do not know, just very quickly, I am just reminding you what is flow. Flow is in a simple language, the number of vehicle crossing a section over a per okay or per time. Okay. What is the speed? Speed is basically nothing but distance covered over what time. Okay. What is density? Density is nothing but number of vehicle over a unit. Okay, if you take a photograph and take a say length of the road is 1 kilometer, count the number of vehicles. Speed, wait in a particular location, so take a certain duration, let the vehicle cross the section, one location to say you have two locations A and B. Okay, like this, two locations A and B, and you know what is the distance between A and B. Okay, so you start timer here at A, so that will be the entry time, and stop timer when the vehicle crosses this point B. So you know the distance, you know the travel time. So distance by time. Floor, you stand in any particular location and go on counting the number of vehicles over unit time. So that will give you the floor. Okay. So this much already we know, and these are the relationships. Now I am going to the main part, that is our relationship is we are interested to find out the density occupancy relationship. Okay, density and occupancy. So first of all, we need to know what is density and what is occupancy. Okay, density already I told you what is density. Density is basically the number of vehicles. I'm still in shortcut I am writing number of vehicle over length of the road. That is basically what is the occupancy? Occupancy is defined as the proportion of a specific data collection time interval that vehicles are present in the detection. What is trying to say that occupancy is basically you have to find out the proportion of the time the vehicle has spent on a detection. So this is your detection section A and section B. This is your first say your total uh, time duration. You are talking about say you for this particular say data collection time your total time duration. Now you see that suppose one vehicle is arrived here and it has crossed the section. So how much time it is spent? Say it is spent time t. Then by that time another vehicle has arrived and it has crossed the section. How much time it is spent? T2. Another vehicle has arrived, it is like that there may be n number of vehicles and they can cross the section within the total time period T. Now sum of this value T1 plus T2 plus T3. Okay, up to T and find out the ratio over original duration of the time. Simple word, what is it in a occupancy defined as the proportion of a specific data collection time interval that vehicles are present. That means what you are finding for over a period of time, how much time the vehicles are present on the detection. Let's say my 1 hour time period was there, and in within 1 hour, how much time the number of vehicles has spent within the detection. Then that will give you the okay. Now say this is a road section and a detector is installed in the road section or say persons are standing in two locations which are having a distance of d. So this is a vehicle. Say this is the ith vehicle which is running with a speed of ui. the length of the vehicle is Li. So how much distance it has to cover total to cross this detector? So whenever just it will touch, when just it starts, say this is just it has started. So this total length is Li. So whenever just it starts, means it is starting the touching the detector, and whenever the tail or the back side or rear side of the vehicle will arrive here. Okay, that means it has total crossed the detector. So how much total distance it is covering? It is basically covering a distance of say Li plus. Now if this vehicle was running with a speed of Ui, say anything, any speed, vehicle, the speed is U. So what is the time it is spent here? Distance by speed is nothing but time. Okay, this much time. So like that, in this particular location, there may be n number of vehicles. So what is the total time spent by the n vehicle? That we can take the summation of this over n. So there was n number of vehicles standing on that particular, right? Now this, what it is said, that this total time spent by n number of vehicle over the total data collection duration. Let us say the total data collection duration is capital T. Then this is nothing but is equal to what? Occupancy. Okay, so understood, clear cut? What is occupancy? Occupancy is nothing but the ratio of the total time spent by the vehicle in the detection zone over the total duration of the data collection, specific data collection time interval. Okay, so this is what is the occupancy that we can write. Okay. Now if I extend this, let us extend this, how we can write? See here, this T is constant. Okay, total time. So 1 upon, then what I can write? Summation of, I can make it two part, Li over Ui plus I am writing. See again, this D is a constant. Detector length you are not going to change. So D over total time, then summation of 1 upon. Can you write like that? Now in this whatever I have written here, occupancy, what are the meaning of the symbol? If you want, you can write down. Let us write down. The Li is nothing but the length of ith vehicle. Okay. Then D is nothing but the length of detector. Fine. Then this T is the already evidence specific time. Okay. So now what I can write? Now let us just copy the equation whatever I have written earlier. Occupancy is equal to 1 upon T summation of Li divided by Ui plus what was written there? D divided by T. Okay, I am multiplying this D with a value of n and I am dividing it with the value of n. And multiplied by T as it is I am writing summation of 1 upon. The question is, what is that n? Why are you multiplying? N is basically, I am talking about the number of vehicles that has crossed the detector. Okay. So now what we can write? Suppose if I separate this two part, n by t, total number of vehicle crosses section over a total duration of time t. What is that? That is nothing but is equal to flow. Okay, so can we write this as a flow? So that means what I can write? I can substitute n by t is nothing but equal to flow. Okay. If I say here that n is the total number of vehicles. Now look at the remaining part. What is remaining part here? Remaining part is what is there? D by n summation of 1 upon. Here speed means we are talking about the time in speed. Okay, if you do you remember the relationship between the timing speed and specimen speed that I have told you earlier? What was that specimen speed? Specimen speed is nothing but equal to, if you say the n is the total number of vehicle, then divided by sum of 1 upon ui is the timing speed, right? So from here what I can write? Here I can write that specimen speed into summation of 1 upon ui is nothing but equal to n, or what we can write? We can write 1 upon n summation of 1 into 1 upon ui is nothing but equal to what? If I bring it that, then nothing but equal to 1 upon etc. So here I can replace that. Okay, so here I can keep d and the remaining part I can replace it. So what we can write from here? We can write that occupancy occupancy is equal to 1 upon t, as it is I am writing the first term, summation of li divided by ui plus what I said, n upon t. N upon t is nothing but equal to flow, that is flow q, right? Flow q. Then in this equation there was a d, so d left, so q into t divided by, this is nothing but equal to 1 upon q bar s, so q bar, very simple you can write. Now what is q by q bar s? Flow upon specimen speed. What we have written? Flow equal to density into average specimen speed. So flow upon average specimen speed is nothing but is equal to density. So simply what we can write? This is equal to 1 upon t summation of li over ui plus k into t. Simply we can write here. Write down here. You can give some equation number if you want. So maybe say initially whenever we have written the first equation, let us say this was this part. Continuation we can give, maybe what was our continuation earlier? It was 5. So let us say this is our equation number 6, right? Then this one you can give as equation number 7, fine. And then from there what we got? We got this value. So this is equation number 8, and then we got this one. Okay, so this is equation number 9. Substitute this is what we have done. We have done this way. This is nothing but okay, that is equation number 9. Okay, now next part. Now what you do? You multiply this in equation 9. In equation 9, multiply by n by n to the first term. To the first, and what is this t? T is the total time. Total time is nothing but equal to what we know. Total time is nothing but equal to sum of the time headway. If I say that time headway individual vehicle is hi, then sum of the time headway is nothing but equal to. So now let us see from 9 what we can get. From 9 we can write occupancy is equal to, what I am doing, I am multiplying by n here divided by n is summation of li by ui plus kd or dk, you can write, and this time I am writing like this 1 upon t, write like that, don't write 1 upon t. Here what we can do, we can write this t we have write, so this n divided by n, in place of t what I am writing is summation of h, okay, then summation of li by ui plus k. This is equal to what I can write, I am taking 1 upon n, 1 n I am taking from here, then summation of Li over EY. Now this you divide, this you divide by summation of Hi by n. This n I brought it down. Okay, this n I have taken here together. So this I can write plus d. Okay. Now what will you get? So from here what we can write? This will give me that occupancy is equal to 1 upon n summation of Li by what was that Ui. Now you see on the denominator what was written. Denominator it was written that summation of Hi by n. Total time here divided by number of vehicles. Total time here divided by number of vehicles will give you average time headway. So what is the average time here that we have written earlier? If you just go back that, where was that? Average time here we have denoted by h bar. Okay. So I have written here as h bar plus d. Okay. So this is equal to, I can simply write 1 upon h bar. Now you see, now here the length of the vehicles, it may be different for different types of vehicles, but for the simplicity purpose we can assume that the length of all the vehicles are same. So let us say the length of all the vehicles are L. So what I can write here, I can take out L outside, L into n or into 1 upon n. Okay, I am assuming that all the vehicles are having same length. So it is L. So L I am taking off. So what is left? Summation of 1 upon Ui plus V. Okay. Now you see here. That what is left here? Here L I have already written here. So L I am writing here. Okay. Then this part. This part. This part just what we have written 1 upon n into summation of 1 upon time headway. Okay, so what is that? Just if you go back here, here what we have written, here we have just derived that this value is nothing but equal to 1 upon average space. So you replace here L into 1 upon this part is coming 1 upon average, right? Then also what is left here? This part is 1 upon h bar plus. Now what is 1 upon h bar? What was the h bar that we have calculated earlier? If you come back in this part, where was it? H bar is what? Average time headway. And what is average time headway? Average time headway is nothing but equal to inverse of the flow. So in place of h inverse, I can write 1 upon q. Q means what? Flow. Okay, right? So average time headway is nothing but equal to inverse of the flow. So you can see here, in place of average time headway, next equation I write L divided by space length is, what is that? 1 upon h bar is nothing but equal to, because h bar is 1 upon q, so 1 upon h bar is nothing but equal to plus d into. Now what we can do here, can we take anything outside? Just look at this equation and tell me. So what is q divided by h us bar? Flow divided by space length speed is nothing but equal to density. That we know already that flow is equal to density into average space length. So flow divided by average space length is nothing but equal to density. So that means I can write L into K here plus D. Okay. So the next part will be left. So occupancy is equal to, you take K common, L plus D. So this is the relationship. Basically, this is the relationship that that occupancy is equal to average length of the vehicle plus detector length times the density. You can give another term here. Some book will find that they are written like occupancy is equal to CK. Okay, simple one term CK, where CK is nothing but equal to length of the vehicle, average length of the vehicle L plus the detector length. Okay, so this L plus D will always be constant. We can assume that's constant. So this is the relationship between the occupancy and okay. You can take an example and you can solve the problem. So practice this part, whatever we have discussed till now. Okay, and next in our regular class, I'll give you one example and you have to solve it in the regular class. Okay, to understand this part, whatever we have discussed. Okay, so this is basically occupancy. Then we can easily find out, you can easily solve. Okay, basically I will give you to find out the density from the so these are the fundamental relationship and that you need to understand. You will only can understand that if you know the basic part. So what are the basic part that I have told you earlier? Basic relationship between 1 to 5. Basically what is flow density relationship. Okay, this one. Then the second one that I have to what is the space and speed. Okay, then I have to what is the density in terms of flow and travel time. Okay, then I said average space headway. What is that? Average space headway to speed in average time headway, and the last one that was the average time headway into average travel time over unit distance. So travel time basically into average space. Okay, so these are the relationship which are applied here mainly. Okay, for different stages that you have seen, and you can calculate it. Okay, so this equation is not looking good like that, so I straight line not looking. So what we have written? We have written that occupancy. Occupancy, occupancy is equal to summation of Li plus D over speed of the vehicle total divided by the then I have to okay. So this way you can go through this part and you can easily done. Okay. That's all for today in this class. So we'll come with the next topics on our next class. Okay. Thank you.